Okay, like I promised, a bit more about pie charts. Here's your task. Find the biggest piece of pie in each of these, in A, B, and C. Which piece of pie is biggest? Okay, if you said 5, 4, and 1, you are correct. Here are the corresponding bar charts showing the sizes of each piece of the pie. It's tricky. Hopefully you noticed that this is tricky. It's a hard comparison to make. Now imagine that A, B, and C represent 3 consecutive years, and your task was to determine how well 2 was performing relative to 3 over time. PU. Yeah, you'd hate that job. Often pie charts are used deleteriously. Repeated colors, too many slices, illegible labels, percents that don't total 100. The list of grievances with pie charts is often very long and really usually result from just bad decisions made by the chart creator. Just for giggles, pie charts should be used never, seldom, or undecided. Pie charts are great for showing one set of values, a small set, 2 to 3 parts that comprise a whole. But we've also discussed the difficulty in decoding angles and showing change over time for multiple variables. There are other options for showing parts of a whole. We've talked about that in the last video. This stacked bar chart is one option. Is it easier for you to read, though, than the pie chart? For me, it's not. But if I were trying to compare how never, in blue, changed between, say, 10 different polling dates, it definitely would be easier for me to use the one on the right. Here we're showing change in fractions over time. This is the pie chart here. So again, boring examples, 2015 through 2018, furniture, office supplies, technology. But looking at the change over time and how these proportions are shifting is really difficult. This is called a dumbbell chart. There's no visible scale on the x-axis, but the labels imply that there is a consistent scale. Humans are really good at detecting distances between objects and placement along a scale. We aren't used to seeing data plotted this way, though, so there's definitely a steeper learning curve. But with a little explanation, I'd argue that this dumbbell chart is a more effective way to make the comparison over time. It's easier to see which category is performing better each year. And it's also easier to get a clearer sense of the magnitude, how much better or worse the performance is, just by looking at the distance between the points. It's easy to track red and say, oh, I can see what red is doing. So the dumbbell chart is much more efficient and effective, but definitely takes some explanation. Variance between them might not be important to you at all. Maybe you want to show a ranking among the categories over time. And in that case, you might want to use a bump chart. The biggest pro for the bump chart is that it's really effective at visualizing rank. But on the cons side, they get noisy if the ranks change a lot or if you have a lot of categories. Like with the dumbbell chart, viewers likely won't realize that you're comparing parts with the whole. So you have to be careful and include some explanations for these, but bump charts show how the rank changes over time. And notice that time has shifted to the x-axis here. Okay, here is an example of a slightly more busy bump chart showing color popularity for cars. New cars in North America from 2000 to 2015. So each column up and down is a year. So again, we're tracking with time logically. And the colors are just ranked by popularity. I don't know if it's total sales. I don't know where it is. But it's just purely a rank. So if you wanted to see what happened, where black cars rank over time, it's really easy to just track what the popularity is. But that's all the information we're getting. We don't know how much more popular white is than black, or gray is than silver, or red is than blue. All we know is the order that they fall in. Poor beige. Somebody across the street from me, I just thought of this, is selling a beige Fiat. I just noticed that on my way home today. And I thought, ooh, a beige car? Weird. Okay, so the first two suggestions, the dumbbell and the bump plots, are different approaches to variance and ranking. Sometimes you just need a simple way to convey the parts with the whole. And so I introduce you to the donut chart. It's the same shape as a pie chart, but the empty space in the middle is a free space that we can use to add totals or some other bit of data. The downside of the donut is that it's generally more difficult for humans to register the difference in the arc length or the arc areas. So we lose the angle. And so it does make it a little bit more difficult for us to decode the comparison. Yeah, okay. Tree maps, we talked about these before. Again, instead of decoding the angle to designate the proportions, we're registering the differences in the area. And I want to quickly mention the specifics of this ranking that I'm talking about. Cleveland and McGill are the ones that did this really revolutionary scientific study on how accurately humans can decode different kinds of charts and graphs depending on how the data was encoded. We're going to talk about this a lot in a couple of weeks, but I just want to show you this, and I recommend that you pause and take a look at it really quick. But more accurate judgments are easier when gauging the position along a common aligned scale. That's that consistent baseline that I was talking about. And whether you're decoding a length or a height, also area, that's the easiest for humans, and you're going to get the most accurate reading of your plots. 2D position along a common scale, but they're not aligned. So the scale along these is the same, but we don't have, the charts aren't lined up with one another. Length is less easy for us. This is like when you have an inconsistent baseline. We can still decode length, and we can see the differences between them, but it takes a lot more cognitive work. Slope and angle, areas of circles and rectangles, volumes even harder, and color intensity, like how light or dark colors are. And then last but not least, these allow just for more generic judgments. They show trends, things like that are differences between colors. So this is the Cleveland and McGill ranking, effectiveness ranking for how humans are able to perceive some of these things and decode charts and graphs. Okay, so a single tree map isn't necessarily easier to decode than an individual pie chart, but think about alternatives, right? Tree maps tend to be more effective when you're dealing with nested variables, subcategories, and hopefully you can see that it is a pretty solid way of presenting a lot of information at once. Another way, here's a pie chart showing a whole bunch of TechCrunch things, is just to put it in a bar chart. If you really want people to know that it's totaling, that these are totaling a whole, sum it and put 100% down at the bottom. But this is going to be much easier for people to understand and easier to read, cleaner than this. So stick with bar charts. Bars are best. I told you that I was going to come back to the waffle chart. This is showing what I was trying to get at, that it's an effective way to show differences next to each other. So while it wasn't necessarily effective at showing the three parts of the pie chart, to show 43 or 44% to 66 to 89%, it is pretty effective at showing that. Now this isn't change over time, this is just survival rates. But right below it, they are showing survival rates over time. Again, very clean, no axis, we don't need axes, just a start and an end year, and a summary statistic for the overall increase or decrease in the rate for that time period. Simple, clear, elegant messaging. Well done. And then sometimes the pie chart is just the best choice for the punchline. It really doesn't matter how legible the thing is or how easy it is to decode the angles. It doesn't matter. It's just that the average person during a zombie apocalypse is going to taste delicious. So pie chart, rules of thumb. Use these for part to whole comparisons. Use a very small and controlled number of slices. Sort the values. Start at 12 o'clock. Wrap clockwise. When you can, use alternatives like bar charts. And don't expect your audience to compare changes between bar charts over time. But they are relatively space efficient.